Hello friends, welcome to my channel. My name is Obhijit Dhar and today I am going to discuss a very important topic called recursion. What is recursion? Recursion is a process by which a function calls itself directly or indirectly. The corresponding function is called a recursive function. Now, when a function calls itself repeatedly, it is called a recursive function. For some complex program like Tower of Hanoi or in-order, pre-order, post-order traversal, depth first search, or the sorting algorithm like quick sort, merge sort, in that particular case, recursion take a very important role. One thing we have to remember, recursion follow stack. Let's take an example. Look at this. It is a main function, void main. We take an example of C program. This is a main function. In main function, I just print a value called hello and then I again call main function. Now look at this main function, call main function. So that is an example of recursion. So how this program will execute? Look at this. This one is my main function. In main function or inside main function, I print hello and then I again call main function. So whenever I call this main function, it creates a memory block. This is what is the name of this function? That is main, because I call the main function again. So it will print hello and then it will again call main function. So whenever it again call main function or itself, it will create another memory block with same function name main and it will print hello and finally it will call itself again. So in this program, main function call itself repeatedly. So how many time it will call? It will call an infinite number of time. Why? Because we don't put any base conditions there. Now what is base condition? We will discuss in our next example. Now we have already said that recursion follow a stack method. Now if I write this one using like stack, so first the main function print hello, then it will call again main function, it will put hello, then hello, then hello. In this way it will constantly put the value hello and constantly call the main function. So how much time it will execute? As we have already said that we don't have any base condition, that means it goes up to infinite loop. Okay, so it will create what? It will create a stack overflow problem and this is called a runtime problem. Okay. Now in my next example we will discuss about a very popular problem called a factorial of a number using recursion. So let's concentrate on this. Look at this. This is a very popular problem. It's a factorial using recursion. So in this program, what I actually do, just take a number from user and store the value in n, and finally I call the factorial function, and this one is factorial function, and whatever the value actually returned by the factorial function is stored in f, and finally this value is show in this print using printf function. If you have problem in function, so check my function tutorial. Okay, now this one is a factorial function. This is a sub function or function definition we can say. So what is the value of n? That means we just suppose if we put value like 4 or 5, these values comes here, and finally check if the value of n equal to 0. If it is 0, then return 1, Otherwise, this function called repeatedly. This is a recursive function. Now, I just want to explain this one. Look at this. Suppose this one is my main function. So main function, I put the number like enter number. For example, user put n equal to 4. And finally, the f equal to factorial 4. So inside main function, we call the factorial function. So whenever we call the factorial function, so it actually call this factorial function. So this one is my first call. This one from this factorial, it actually call this sub function. So whenever we call this factorial, so what is the value of factorial? That is 4. So it checks if n equal to 0. If n equal to 0, it says no. The value of n is 4, so it is not equal to 0. So whenever it is not equal to 0, it actually it actually goes to where? That is in else part. So in else part, it will return what? That is return n into factorial n minus 1. That means it return what? That is 4 into factorial 4 minus 1, 4n minus 1 or 4 minus 1, that is 3. Now we don't know what is the value of factorial 3, and for that it will again call the factorial function. And the interesting part is that in this particular position, this function get paused. Actually, it will wait for the result of factorial 3, and for that it will call the factorial 3 function. Look at this. Now it will call what? That is factorial 3 function. So first it will check the value of n is equal to 0. Again the answer is no. So it goes to where? That is in return part, else part, and it will return what? That is 3 into factorial 3 minus 1, that is 2. So again we don't know the value of factorial 2. So this function again get paused, and it will call the factorial function again. So comes here, the next function is factorial 2. Because we don't know the result. We don't know the result of factorial 3. We don't know the result of factorial 2. So it will call repeatedly unless it reaches to its n, that is the value of n equal to 0. It is my base condition. So here what is the value of factorial? 2. So it checks if n equal to 0. Again the answer is no. So in else part it will return what? It will return n into, that is 2 into factorial 2 minus 1, that is 1. We know the value of factorial 1? Again no. So what happened? Again it will call factorial function. So it will call factorial function again. So this one is factorial 1. Check whether the value of n equal to 0. The answer is no. So it again comes to else part and return what? Return 1 into factorial 0. Now again I don't know the value of factorial 0. So this function again get paused. This function again get paused, and finally it will call what? That is factorial 0. Look at this. Now it checks if n equal to 0. Now the answer is yes. So whenever it got the answer, it first time return a value. Look at this. In this step, this step, it will not get any particular value. But in this particular step, it will first get a value, that is 1. So this one is comes to where? That in this particular function. So it will get result 1 into factorial 0. What is the value of factorial 0? That is 1. So it will put here 1, and it will return 1 into 1 1 to its previous function. That actually wait for it the result. That is factorial 1. Now what is the value of factorial 1? We know that is 1. So 1 comes here, and this one is 1. So 2 into 1, the result is what? That is 2. So this 2 comes where? That in this particular part. So this 2 comes where? In this particular part. So what is the value of factorial 2? What is the value of factorial 2? This one is 2. So it will put 2 here, and the result is what? That is 3 into 2. 3 into 2, that is 6. So it will return what? That is 6. So this 6 is comes where? In this factorial 3. All are wait for the result, okay, and get paused. Now whenever we reach final condition, we again use the backward method. First it use forward method, then it again use the backward method in stack. So first it stored the value, then it actually pop the value from last condition. That is, it actually follow the LIFO method, last in first out. So value is what? That is 6. So this value comes where? In this position. Now 4 into 6 is what? That is 24. And finally this 24 comes where? That is in this condition, in F. So what is the value of F now? That is 24. So whenever we print the value, that is factorial is %d comma f, so it will print what? That is 24. So if I put the value of n is 4, then the result is what? That is 24. Okay. In my next tutorial, we will discuss about some more explanation of recursion function, like sum of digit, prime number, or like GCD of a number. So keep watching. Thank you.